Okay, so we're gonna talk about first this thing called thrust. Thrust. Right. Let's understand thrust. So to understand thrust, I need to do some drawing. Otherwise, you'll not understand. Tick, 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 tick. Okay. Right. And let's say suppose. Hey, no talk. I am drawing this to make you get settled. Otherwise, I could have done freehand. I'm just buying time. Okay. So first, let's understand thrust. So far, in order to understand thrust, you should have a knowledge of what is force. By now, you have a knowledge of what is force, right? Let's say we have some forces that are acting on this particular. Let's take up the. Let's say this is right now parked on. Right now parked on a ground. Okay, just try and imagine. It's a 3D figure, so the ground also. So the table should also be somewhat like in this manner. Okay, this is the table. Right, this is parked on a table. Okay, and I'm concentrating on the top surface, which is ABCD. Okay, I'm concentrating on the top surface, that is ABCD. Pay attention, then only you'll understand. नहीं तो नहीं समझेगा. Okay, now what do I mean by thrust? Thrust is also force, but is something special about it. So what do we do? Say, for example, I've taken the axis of this particular. Okay, this is the axis of the top part, and let me also have a vertical axis. When you talk about thrust, right now I'm showing at the midpoint, it can be anywhere. Thrust is the vertical force that acts on any surface. Vertical force or the vertical component of a force. What is component of a force? That we will understand in next chapter. So in order to understand thrust, I'll be drawing it with red color now. Thrust is this force, which is acting at 90 degree to the surface, means it should be acting at 90 degree. Let me show another force which is acting on this surface. Let's say this is another force which is acting. This won't qualify as thrust. Let's say this is F1 and let's say this is F. Only F qualifies as thrust. Okay, only F qualifies as thrust. Then you understand. Any body on it, a lot of forces are acting. Say the forces are acting this way, this way. Now you have to take one surface of the body. Let's say I'm talking about this duster and I'm interested to find out the thrust. So if this is the surface that I'm interested, this is the area, then the force should act at 90 degree to it. If it is acting like this, no, it's not thrust. If it is acting like this, it is thrust for this surface, not for this. If it is like this, it is thrust for this surface. So in order to tell about thrust, if you now observe the definition carefully, if you think about thrust, there are two things. You need a force, right? And you also need a surface on which the force is acting, right? So this is, we are trying to define thrust, and now we have to put the relationship between these two. So we need a force and also we need the surface on which is acting. In our example, the surface is say ABCD, and we have two forces out here, but I will be considering F only and I'll rule out F1. Why? Because this force F is the perpendicular force. Perpendicular force. Or in higher classes, you will understand the perpendicular component. It is either the perpendicular force or the perpendicular component of force. लिख लो, component of force. ये बाद में समझाएंगे. Acting on the surface. So if you say, what do you understand by thrust on a surface? A thrust on a surface is the perpendicular component of the force acting on the surface. Is this much clear? There may be 3-4 forces, like say F1 is also a force. F1 is not a thrust because F1 is not acting perpendicularly. Then another question might be also like this, okay? Say suppose there is a force which is acting like this. Let's put a force F2. Now let's see this force. This force is F2. Is F2 a thrust for ABCD? No. F2 is a thrust for CDEF. Say this is a thrust force. So we'll say F2 is perpendicular to which face? We'll say CDEF. So once this is there, then F2 is also the thrust. This is the thrust and is the thrust for CDEF. Okay? Understood? And this F1 is acting at an angle theta, and theta is not equal to 90 degree. Theta is not equal to 90 degree. Therefore, F1 is not a thrust. It's definitely a force, but it's not a thrust. Clear? समझ में आ गया? चलिए. So this was your topic 1 of today. You have to learn about what is a thrust and learn about topic 2 now. What happened? Shaurya darling? Shaurya darling?
Yeah, I think
Bangalore? You could travel? Achha.
So sir, ABCD surface पे जिधर भी पूरा perpendicular.
It could not be. It's not that it has to act here. It has to can be anywhere. And the only criteria is that it should be acting perpendicularly on that face. Then it is thrust. If it doesn't act perpendicularly, it's not that. Is this much understood? Okay, chalo. Our next topic would be about pressure. So in lower grades, many of you have written a definition. Pressure is force acting per unit area, but that is wrong. That force is a special force. That's why we learned about thrust. This is not going to cause pressure. This one will cause pressure. Why we studied about thrust? Okay. Now pressure. Pressure is defined as the ratio of perpendicular force upon the area on which it is acting. Perpendicular force upon the area. And perpendicular force is known as thrust. Thrust upon area. ठीक है, ऊपर से लगता है तो thrust बोलते हैं, नीचे से लगता है तो आप thrust बोलते हैं. ठीक है, perpendicular force. So let's put this area as, say, let this be L and let this be B, okay, and let this thing be H. So if you look for surface ABCD, the pressure is denoted by P. P will be given as, what is thrust? F upon the area of ABCD, and the area of ABCD is L into B. Did you understand this? Okay. And if you want to do it for, say, this is for A, and then do it for B, for surface CDEF, tell me what should be the pressure. If we say this is pressure P1, then this is P2. P2 should be equal to the force, which is F2 upon the area. What is the area here? B into H. This is simple mensuration.
Yeah.
B into H. Okay? Clear hua? How to calculate? So the next thing would be to find out what is the SI unit of pressure. And now here I will teach you all units because you have learned what is MKS in the other class. SI unit of pressure. So SI unit of pressure will be given birth by what? SI unit of force and SI unit of area. So what is the SI unit of force? Newton. What is the SI unit of area? Meter square. So this is written as Newton meter minus 2, and a special name is given to it as Pascal, written as PA. Okay. So we should be in a position now to define what is 1 Pascal. Can we define? 1 Pascal, the pressure acting on a surface is said to be on a surface of 1 meter, or on a surface of 1 meter square, or the pressure acting on a surface is said to be 1 Pascal when a force of 1 Newton acts on an area of 1 meter square. This is 1 Pascal is said to be the pressure when a force of 1 Newton acts on an area. So 1 Pascal will be said as is the pressure is said to be the pressure when a force of 1 Newton acts on a surface of 1 meter square area. And pressure is always a scalar quantity. Pressure scalar होता है, though one of the parent is vector. So far clear, Sanvi madam and Sudriti madam? Clear? Sudriti madam, there is sleep in your eyes. What happened? No? Good. And where are your specs?
Good question, sir.
Ah.
Sir, you notice everything, sir.
Ah. Eyes should be wide open, na? I can't be a Sarthak that I come with pencil box and I go away without the pencil box.
That's a big watch also.
Watch, specs. Only thing he absorbs from my house is drinking water. I'll tell his father that one thing your son has always had a takeaway is water. Baki padhai gyan, I'm not that much sure, but he ensures he drinks water every day. Okay. So what is the unit of pressure? Pascal, and it's a scalar quantity. Sometimes you will be also denoting a very bigger quantity which is known as kilopascal. Kilopascal. So 1 kilopascal is equal to 1000 Pascal. Rascal mat bol dena, hai na? So this is denoted as 1 kPa. 1 kPa. ये भी आएगा प्रॉब्लम में. Let's also dive into our section because we spoke about MKS a lot the other day. So now let me see who can help me. How do you think should be the unit for pressure in MKS? Pressure in MKS. Try if you have studied last class mass and weight, then it should be. Pressure is given by what? Force upon area. So this is given by force upon area. बहुत easy है. Area, whether you are in SI or metric, your area will always be meter square. But not kgf m square. Very good, Vanya. We will use kgf out here for force, and area के लिए हम cm square use करते हैं. Okay, so this unit will be kg force per cm square. So next time you see a pressure gauge out here basement में कहीं में and it's showing pressure, you will see it shows kg per cm square. That is what I told you. Those are wrong gauges. If it's correct gauge, yes, the F may be written in brackets. That's a different thing. Okay, let's be now British. Let's do pressure in FPS system. FPS, foot pound. FPS, foot pound second. Okay, this is a British system. Again, force per unit area. How do the British people talk about force? Pound. The pound is written as LB, right? A pound. And what should be the area? I told you. दुकान में जाने से क्या? Inch. दुकान वाला हमेशा inch में बात करेगा. Pound per inch square. And this is what you talk about as PSI. PSI बोलता है ना, गाड़ी में जो हवा डालते हो ना रोज फ्यूल स्टेशन में, that is in this one. G is gauge. Gauge means you are measuring above the atmospheric pressure. So when you go to a fuel station and you inflate your car tire, you are not inflating as per this. You are not inflating as per this. You can do it. That system, there will be a switch called mode. Again, you can select the units. Just like in temperature, we have got Celsius and Fahrenheit. If you go to US, you make it Fahrenheit. But our people, always dumbos, our people, if you set it Pascal, how many of you took the time to read that car wala thing on the car? That will, after that class, how many of you sat in your cars? Honest question. Car. After last class, you were not there in that last class.
I was there.
Mass and weight, you were not there. Mass and weight, you were in match in which you were the captain. The match was supposed to end by 5, but it didn't end by 5.
Physics.
You were not there. Okay, now tell me, How many of you saw that label? I told you which seat? Driver's seat, driver's door. It will be written. That is your interest. If you see there, they will give you how you should inflate your tire in kilopascal. They'll give you this also. But if you go to the fuel station, he'll first say, "Sab 36 डालो, कार होने से 34 करूँ, बाइक होने से और ज़्यादा करेगा 38 or something like that." 36 means 36 means what is going for PSI. ठीक है?
And then you also said that you did this other experiment where you.
Now you will remember everything because what has happened now, the jolting has happened. Now we will remember everything. Now you will even remember how you went back from my house. But you should remember it as a part of your study. Have you understood pressure? Fine. Can I rub this portion? Okay. We'll go a little bit more deeper into pressure now. All these you have learnt in grade 8. However, you will get problems only on this unit. But if you are a ICSC guy, in grade 7 you will get problems on this. Therefore, your mathematics improves, your interconversion improves. हाँ, grade 7 में हो जाता है उनका. Can you convert? Can you try? Let's see. Let's do mathematics. ये side मिटाऊं? ठीक है, आ जाओ. Convert करने की कोशिश करते हैं. Let's try and convert. Let's try and convert KGF. यही तो this is physics all about. KGF per cm square. Let's try to convert it to Newton per meter square. Let's try, and then we'll check on Google whether we are correct or not. Okay, KGF to Newton. Right. Now let's go by basic. Kg force. What is force all about? Force is mass into acceleration. Now this is typically when you are talking about force means this is thrust. Okay, the acceleration is acceleration. So what does 1 kg force tell you? In MKS, a body of mass 1 kg exerts a force of 1 kg force. But in SI, it's not like that. 1 kg will be 9.8 Newton. समझ में आया पहले? So यहाँ पे for this 1 kg force we will put 9.81 Newton. Have you understood? Now नीचे क्या है? Centimeter square. Each centimeter is how much? 1 upon 100 meters. Centimeter square. 1 upon 100 into 1 upon 100. This is Newton. Don't you think this is meter square now? And this side I can write 1 kgf per cm square. 1 cm square. 1 kgf is 9.81 Newton. And 1 centimeter square is 1 centimeter means 1 centimeter as 1 meter, 1 by 100, 1 by 100 meters. Have you understood? Or still doubt? Can you now convert this? करो, इसको convert करो, कितना होगा? This will be 9.81, okay, divided by 1 by 100 into 1 by 100, divided by 1 by. So this will get multiplied by 100. Yes or no? This is divided by 1 by. क्या इतना हाथ से करो ना, यहाँ देखते क्या रहते हो, खुद करके देख. 1 by 100, 1 by 100. So much, and then this becomes Newton per meter square, which is equal to 9.81 into 10 into how many? If you make it 10 to the power, yeah. So if you make it 10 to the power, so this is 10 square, more square, 10 to the power 4 Pascal. You yourself can make your own units if your unit is through. वैसे कोई पूछेगा नहीं, पर ये आना चाहिए. पाउंड कर सकते हो, ठीक है? चलिए, let's go to some more study now in terms of pressure. Now questions that will come to you. Let's go for questions that will be asked to you. Let's just look at the relation of pressure. Pressure is given as thrust upon area. Okay, which means that pressure, if this is denoted by P, and if this is denoted by F, and if this is denoted by A, pressure is directly proportional to force, number 1, and number 2, pressure is inversely proportional to area. Let's see some of the examples for this first. Okay, the best example for this is the gardening hose, gardening water hose, or the water pipe. Right. Where do you connect it? We connect it to a tap. Right? Let's see the first relation. If you increase the flow of the tap, the pressure increases. Right? Another way is, suppose you have increased it and you have opened the tap to the maximum possible, and the water is not going to the rose plant that you want it to go. What do? You squeeze the pipe at the head. So what you have done, you have actually, if the orifice of the pipe was this orifice, means the outlet, then you put your thumb into the pipe in such a way that this much place you have blocked it. You only allow the water to come up from this. Isn't this area less than the full area? So what did you do? You reduce the area. If you reduce the denominator, the quotient goes up. Have you understood how pressure increases? एक बार फिर से बताऊं? Right. See, look at. Sorry, I was on this side. Look at the equation. Pressure equal to thrust upon area. In any sort of a fraction, if the denominator goes down, the numerator is going to climb. Sorry, the quotient is going to climb up. Or if keep this constant, and it's like mangoes and number of kids, and this is the dividend. Okay, if the number of mangoes increases, you are a happy kid. You'll get more mangoes per person. Or else you reduce the number of kids, then you get more mangoes as a person. Now just put it this way. Now we have connected our gardening water hose to a tap, and say we still have some more turns to go. So if you open up, the pressure increases. You can't change the area of the pipe. The area of the pipe is as manufactured. Now suppose you have opened the tap fully, and now water is no more reaching to the plant that you wanted to go. What do? Now you put your thumb on the, so when you put your thumb, you have actually reduced the area through which the water is coming out. So if you reduce the area, the pressure increases. Take, there's a second one, some more examples of it. Now some lovely example. Where has it gone? Yeah. Can I rub this part? This in grade 8 I have told all these things before also. Same example. बहुत serious हो गए हो ना, थोड़ा light हो जाओ क्या? Don't worry, I'll handle it with your dad. Yeah, very well. ठीक है? So okay. So you have an elephant, and I'm not drawing completely. You have a beautiful lady, but with the stilettos on, and to decide as your dance partner for the Christmas ball dance. Okay, so whom should you select? Okay, a beautiful lady and elephant out here. And imagining that the elephant is also the baby elephant, not that my baby elephant, when it's born, it's around 96 kilo weight. Okay, so you have a lady and this. Now look at it. Now there's a chance that your partner, whether it's the elephant or the lady, is not so good in dancing. So there's a chance that he or she might step on your feet. Okay, so if this fellow steps on your feet, this fellow's legs are somewhat like this. Don't you agree? Right? And if you see the cross-sectional view, this much is going to come on your feet. Force per unit area. What is the area? Area is big area, A. And Mrs. Briganza, if she puts her feet on you, the area is this much. A. Yes. So don't see a beautiful lady and immediately agree to dance if she doesn't know to dance. You'll have the pain of your life. Because when she steps on you, the pressure will be very high. Force per unit area. Imagining that both of them will give you the same force, her area is very less. So if you go by this equation, the area is less, the pressure will be more, your scream will be much more high. Gir gaya to. Okay? Now the next question. Many people again have an issue. Should a sharper needle hurt you less when you are going for an injection? What should you ask for? If you are going for an injection, okay, if you are going for an injection, you will get the injection. You can't run away from it. Simple. So, how sharp the needle should be?
Very sharp.
Very sharp. Why? It will easily penetrate inside. And many people think sharp needle, it will pain me. Then just put the example like this: take a screw and take the needle. If I want to give an injection with a screw, how will I give you? Like this, I'll give it. Because a sharp needle's cross-sectional area will be very less.
If you don't take a sharp needle, it will be brittle. So like the area will be.
Not area under contact. This is a blunt needle. Do you get me? This is a blunt needle. So how much area is under contact? This much is under contact. And this is a sharp needle. So how much area is under contact? This. So anyway, I have to push it in your body. So the force required by me to push in your body will be less in this case. so that will hurt you less. Got it? Sometimes, many a times you go to these rose plants and cactus and all, you just get you get a sting, knowingly or unknowingly. But imagine getting a sting from a nail or something, the pain is much more. Now the next question comes up is, why does a sharp knife cut more easily than a blunt knife? So if you see the sharp knife, the area of the sharp knife is very a knife is always like this, V means, suppose this is the blade of the knife, the blade of the knife will be like V.
Yeah.
We just sharpen it in this way, V. Okay, so the more V it is going to cut something much more easily. Then, have you seen Amazon and other people coming to your house for delivery with those big bags? If you see their shoulder straps are this big, very thick, because the weight is much more. Right? So if the area is more, the pressure is less. Imagine they have been given noodle strap type strap, दे दिया उसको, हाथ काट के गब्बर ये हाथ ले जाओ, hands will just pass out. Clear example? So they will give you questions like, why do school bags have got broader straps? Then let's see a tractor. A tractor is a very heavy vehicle. How is the tire of the tractor? Much more wide. As such, it reduces the tractor actually moves on what? Wet fields. इतना wet कि बाद में tractor ही नीचे चला जाएगा. You don't want that to happen. Look at the army tank. It actually moves on a chain drive. Clear? समझ में आया? How does pressure and force vary? Any questions so far? Now say like for example, you know what is a tack? Brass tack. Tacks. This is known as a tack. Brass tack. Thumb tack. So how do we do those? We actually put a force from our thumb. And if this is not sharp enough, then more force will be required on your thumb. Agreed? So they should be sharp enough. And the force that you give is vertically upward. Just vertical. So that's called thrust. And per unit area. Try to make it so sharp that the area is much more less. And will go in on one shot. Clear? Pressure, force. A question that you might get is, they will give you a brick of this dimension. And they will tell you, when is the pressure more? They will ask you to put the brick in this manner and once in this manner. Don't write the same answer, because when the brick is like this, the area is this into this. And when the brick is in this manner, the area is this into this. Okay, one more last example and you will understand it much more better. Now this is the new sofa that you all have bought from IKEA. And this is the cushion part, okay? And say, our Pratichi is dancing on this sofa like a trampoline, and this layer of the sofa is now becoming this way, right? She gets a phatka from her mom. Why are you doing this thing? Same Pratichi, when she is ill, her mom only says, "Beta so ke khana kha lo, TV dekh ke." Yahan pe. What is the difference in these two cases? Pratichi's weight is same in both cases, but her contact area is much less in this case. As a result, the pressure will be more and the damage to the sofa will be more. But in this case, फैल गया है. So what is happening? The contact area has increased drastically. As a result, the pressure has fallen down, and now the damage on the sofa will be less. Clear? Force and pressure. एक आध problem कर लेते हैं. चलो करो. And then we do other things. बहुत कुछ पढ़ लिया. Okay. So we have a rectangular wooden block whose mass is 4 kg. You can write down. Given a rectangular wooden block of mass 4 kg. Where do I write? Where do I write? Okay, I'm writing here. The question is given. Rectangular wooden block. Rectangular wooden block. And it's of 4 kg mass. Okay? 4 kg mass. Length, breadth and height are 50, 25, 10. La, ba, ha. 50, 25 and 10. Everything is in cm. Mind the units, okay? Everything is in cm. Mind the units. Find the pressure on the tabletop. Find the pressure on the tabletop. So you can just take this as the problem. Length is equal to how much? 50. Width is equal to 25. And height is 10. Figure थोड़ा गड़बड़ हो गया. And they've given you the mass. Mass is how much? 4 kg. So on this is the tabletop. Try to find what is the pressure on the tabletop. Find your answers in SI as well as MKS. Find your answers in SI as well as MKS. MKS will be easy now because everything is in centimeter. Okay, MKS will be easy. Height is this one. ये देखो बेटो, height is 10. 10, 25, 50. ठीक है? Do it. So you need to find out the force. Force means thrust. Thrust in this case will be the weight of the block. So if you are doing it in SI, read करने का क्या है? This block is on a table. Find the pressure exerted by it. It's drawn to you. The block is on the table. This block has a mass of 4 kg. Find the pressure it is exerting on this table. This is the table. So what is pressure? Force upon area. What force will be acting on it? The weight of the ball. अरे तुम लोग इतना घन चक्कर होने से कैसे चलेगा? This is the block. The block has got a weight W. What is weight equal to? mg. If you are trying to do it in SI, means this is nothing but your force mg in Newton, and take g equal to 10. It will be easy for you. So what is the force? हाँ बस अब CBSE बच्चा बन गया. What is the fun? जो चीज क्रैक करना था वही नहीं किया. Are you understanding where the mentality works in CBSE problem doing? Thinking power goes down drastically. I increased one more problem for it that I am asking you to do it in MKS also. I want the pressure in MKS. Means you should tell me the result in both Pascal as well as kgf per cm square. हाँ.
G को हमेशा 9.8 ले या फिर 10 ले?
अगर specified नहीं रहता है तो 9.8 लेना चाहिए. अगर specified, if it is 10, they will specify you. Otherwise, if it is not specified, you are supposed to go by 9.8. So here I am telling you to go by 10. It will be easy for you. So if you do it in SI, you have to convert the centimeter square into meter square. I have taught that in your mensuration classes. How to convert centimeter square to meter square. Divide by 1000, 10,000, 100, 100. Or else use exponents. किस दिन काम में आएगा? What is the area of this? What is the area you will be working for it? Applicable area would be what? 50 into 25. Do you agree? So 50 into 10 to the power minus 2 meters into 25 into 10 to the power minus 2. This much meter square. Can you multiply 50 and 25? 25 5 is 125. 1250 into 10 to the power minus 4 meter square. Now bring it in standard form. Then it should be 1.25 into 10 to the power 3 and minus 4 makes it minus 1 meter square. हो गया एरिया. नहीं समझ में आया ना ये? हाँ तो कितना कच्चा हो मैथ्स में सोचो. कितना कच्चा हो. Did you understand? 50 centimeters written in meters. So 50 into 25 is what? 1250. 1250 minus 2 is minus 4. 1250 को स्टैंडर्ड फॉर्म में लिखेंगे तो 1.25 लिखेंगे. ये ग्रेड 8 में था एक्सपोनेंट्स में स्टैंडर्ड फॉर्म. 1.25 करेंगे तो पॉइंट कहाँ आ रहा है? 1 2 3. सो 10 टू द पावर 3. 10 टू द पावर अरे सच में यार 1.250 into 10 to the power 3 into 10 to the power minus 4 meter square. Now can you do it? 3 and minus 4 is minus 1.
Yeah.
What you will do, you will make it 0.5, you will make it 0.25, then you will multiply point and point, then you will goof up one point and then you will say I lost marks. Aparna is already unable to control her laugh, but she was going that way. I can understand. So use your exponents ना, किस दिन काम में आएगा. And what is the weight?
40 kg.
40 kg. 40 kgf नहीं है, 40 Newton. Mass is how much? 4 kg. फिर गलत बोल रहे हो. Mass is 4 kg. So weight is 40 Newton. So the pressure should be equal to 40 divided by 1.25 into 10 to the power minus 1. So this is Newton per meter square. Can you show me a technique in which this can be done in an easy manner? इसको 400 करोगे तो इसका 1.25 का पॉइंट उठ जाएगा, कोई प्रॉब्लम नहीं है. कैसे करोगे इसको फट गया फिर से.
10 to the power minus 1 will take it in fractions.
Get me the answer in kgf per cm square also. That's easy. Kgf per cm square, you'll get the answer in one go.
Sir, 0.032 kgf by cm square.
इसका आंसर कितना आया?
0.032 kgf by cm square.
नहीं, इसका SI में आंसर आया कितना?
ऐसे में कर रहा हूँ.
अच्छा, in MKS how much did you get the answer? Tell me.
0.03.
Okay, let me see how much we got the answer in MKS. So in MKS our answer will be pressure in MKS would be given by force, which should be in kg force, divided by area, which should be in cm square. So force in kg force, what is our mass? 4 kg. A 4 kg mass object has a weight of 4 kg force. Simple, एकदम easy. और एरिया कितना होगा? 50 into 25. What is 50 into 25? 1.1250. 1250 cm square. 4 divided by 1250. वो 32 वाला आंसर राइट ही है. It should be 32 only, correct. .0032 आएगा आंसर, करेक्ट. So this answer is 0.0032 kg force per cm square. And if you actually compare it with Pascal, then this thing should be in meter square, and this thing should be एक 10 यहाँ पे extra आएगा, एक 10 to the power minus 4 यहाँ पे आएगा. So here we will get 40 divided by this is 1.25 is 32. 32 by 10 to the power minus 1, which is equal to 32 into 10, which is equal to 320 Pascal. That will be our answer. ठीक है? Can you now calculate? Just don't calculate. Just think that I have tilted this now. Is this much part over, children?
Yeah.
So you can take any one of the force. Either you look at this force or that. Let's look at that 320. Now we tilt this block and we make it like this. Let's see what happens to the pressure. The force remains the same. So if the area goes up, the pressure should go down. So let's see the area in this case. Area in this case will be 25 into 10 is 250. And in this case, it is how much? 1250. So in this case, the area reduces. The pressure should go up. Yeah, करके भी देख सकते हो. So area is around 250. The pressure will be going up in this case, and the new pressure would be SI में करोगे तो 1600 Newton आ जाता है. Same break. ठीक है? Understood? All of you done? Any doubt in this problem? If there is no, don't get worried about that. I get angry. I am not angry. If you have understood or not, you tell me. This part will not come in your exam. This I am doing for you for your clarity purpose. You will be calculating this part only. You do the way you want. I am only showing you how you can reduce. But yes, they will definitely give you a question. जब इसको उल्टा करेगा, they'll flip this and they'll ask you to calculate the pressure. Only remember, pressure always acts on the surface under consideration. So अगर ये उठ गया तो ये वाला surface आएगा. And this surface, the area is how much in centimeter? Let's see the area in centimeter square. This is 1250. This is how much? 250 less. Now tell me 250 and 1250. How many times of 250 is 1250? 250 multiplied by 4 times is. तुम लोग का ना बेसिक्स कितना कच्चा है. What is 250? In our days, you know what is 250? 250 ग्राम बेसन दीजिए, पौवा. 250. 250 into 4 times makes it 1 kilo.
Yeah.
So 250 into 5 times makes it 1250. So the pressure should also go up 5 times. इसको 5 times कर दो. 500, 5210 and then 1 carry over 5315 plus 1 16. 1600 Newton per meter square, which is 1600 Pascal. When it problem comes in competitive exam, तो इतना थोड़ी करेगा. Just दिमाग लगाओ. What is the change happened? Only the area is changing, right? The area went down by 5 times. So the pressure will go up by 5 times. Here pressure was 320. Now pressure will be 5 times of 320. सब में खाली बैठ के ये ऐसा नहीं. ठीक है, चलिए. If this is over, we can go to any other questions on thrust. Who all have done it in your school so far? So any question? For you, it is reinforcement. आपका syllabus क्या है for Dashera break exams?
We have first two chapters of chemistry.
हाँ नहीं physics जो पूछा जाए वो.
Motion, force and laws of
वो तो मुझे भी पता है. हाँ, और
gravitation.
अभी ग्रेविटेशन क्या पढ़ा रहा है स्कूल में?
Really, wow.
अच्छा, ठीक है. So thrust part is over. Okay. Now after this we have got 2 more parts: fluid pressure, buoyancy, and Archimedes principle, and then we are done with this chapter.
Archimedes will give the value of pi, right?
Pi's value was calculated by Aryabhat, India से accurately.
So zero भी इंडिया में invent हुआ.
हाँ, 0 is attained from India. ठीक है. Now we talk about fluid, and then we'll talk about fluid pressure. Fluid का मतलब क्या हुआ? Fluid is anything that flows. Anything that flows. The most interesting thing is heat is also considered as a fluid, fluidic motion. Anything that flows. It can be visible, it can be invisible. Like heat is not visible to you, but heat is considered as fluid. Anything that flows. So in this chapter particularly, this comes down to say air. Air is also fluid, and water or any other liquid is also considered as a fluid as long as it has the property to flow. So our concentration would be out here when we talk about fluid pressure. Air pressure is not that much covered in your this syllabus. Air pressure was covered more. No, heat is also fluid. Is something fluidic property means anything that can flow is considered to be a fluid. Heat also flows. Like if you heat this part also gets heated. So heat also has fluidic property. We are going to study about so far what you studied. Okay, if I write this, it makes it more clear. The examples and thrust and everything that you saw so far was pressure in solids. Do you understand now, Zoe? This was pressure in solids. We're going to now see about pressure in liquids. What happens? Liquid pressure. Say I take you and I throw you into a swimming pool. You feel some pressure out there. So that is fluid pressure. Or as you are coming down, you are doing bungee jumping or skydiving, then also you feel some pressure. That's air pressure. That's fluid pressure. And in fluid, we will be concentrating more on the liquid part. Air pressure has been dealt more in grade 9. Okay, we're talking. All are fluid pressure. No, in grade 8 you have learned. Atmospheric pressure was there in grade 8. We'll cover that also, don't worry. ठीक है, आ जाओ. Fluid. So I hope you're clear with fluid. Fluid is anything that flows. All liquids are fluid. All gases are also fluid. So air means we can take gases as the bigger family, gases and liquid. So our interest would be in this chapter would be more about water, and air. ठीक है? Few of the things that you should know. Pressure increases with depth. Very, very necessary for you to understand. Now, let's say this is land surface and you are standing out here. Okay, below this is all water, below this is all water, and this is land surface. Okay, so what do you have here? Air. What do you have here? Water. Let's try to see the variation of pressure. Now, if you go down, the pressure increases. Pressure increases. And keep one formula in your mind, though your textbook doesn't say. Pressure is given by rho g into h, where rho this is a Greek letter called rho, rho rho. एक दिन दिखाया था, ऐसे लिखते हैं रो को, उल्टा पी जैसा. लिखो लिखो, तुम नहीं लिखोगे तो 11 में तुम्हें सडनली टीचर बोलेगा रो, एंड दैट टाइम यू थिंक रो रो योर बोट merrily, you don't know anything. Rho is written like this. Okay, rho, there's a Greek letter rho. Okay, let's write one more rho. Rho, one more rho, rho. ठीक है, ठीक है. So pressure is given by the formula rho gh. I hope you have understood what is rho, what is g, what is h. Rho means the density of the fluid. Density. We'll talk about density a little bit later. G, you know, acceleration due to gravity, which is a constant. And h means the depth. Usually the height, the depth. So as you go down and down and down and down, the height increases. And you're going underwater, so the density, the fluid, as long as the fluid does not change, the density does not change. So density remains the same. So how does the pressure depend? Only on depth. अभी जो implosion हो गया था ना, वो नीचे गया था ना, 2.5 लाख पाउंड खर्चा करके नीचे, to see the Titanic wreck and all. Why you can't reach the Titanic? The Titanic is almost 2.5 miles down in the Atlantic. So can you imagine, a submarine cannot go below 500 meters. उसके नीचे जाने से is huge pressure, फट जाएगा. If we take you, the chest will just burst out. The submarine can go maximum up to 500, 600. After that, even the submarine cannot bear that pressure. And Titanic is down how much? 2.4 miles नीचे है वो. So, yeah, so they go under special vessels, right? So those vessels, in fact, the viewing vessel of the Titanic, otherwise, like previously when James Cameron and all who were the directors of Titanic, they used to go, the viewing glass itself is 40 inches thick, through which you see the Titanic wreck. What is the scale? 12 inches. 40 inches thick is that glass, through which you actually see. That much is the pressure below. Okay? So the wreck lies below. That's the reason in grade 8 also you have learned, when you make bridges or dams, the walls of the dams are much more thicker at the bottom, because here they will be facing much more pressure. So this is a question which comes, why do dams and piers of bridges have got thicker walls? Because as you go down, the pressure increases, and the pressure always goes by the formula rho gh. Have you understood? Now second question is, let's talk about density. CBSE has made a joke of this chapter. They have removed density. Also you should know what is density. Density is a ratio. Density is the ratio of mass over volume. So what should be the unit of density? Kg per meter cube. And the density for water, rho for water, is usually 1000 kg per meter cube, or you can also write it as 1 gram per सेंटीमीटर क्यूब. ये सब आईसीसी बच्चे को 7 से आता है, हमें कुछ भी नहीं आता है. देखो, राइट. डेंसिटी टेल्स यू, डेंसिटी इज अ मेजर like how much volume somebody will occupy. Like I ask a question, what is more heavy, 1 kg feathers or 1 kg iron? Generally people say 1 kg iron. नहीं, I said 1 kg, दोनों एक ही है. But 1 kg iron को आप पॉकेट में ला सकता है, 1 kg feather को आप सेंटा क्लॉज बन के आएगा ऐसे करके. Volume is much more. Have you understood? So density किसका ज्यादा है? आयरन का ज्यादा है. If your density is more, you need less packing space. If your density is less, you need more packing space. So the cushion, a 5 kg cushion will be very big, whereas a 5 kg Ashirwad atta comes in this much packet. Density is much more. Have you understood now density? So Anything which is more heavy has got more density. Now you tell me, plain water, salt water, which is more heavy? Salt water, obviously. So if you see in sea, the density of sea water is actually more than the density of river water, obviously, because of the salts out there. So sea water में जब आप नीचे जाओगे density ज़्यादा है ना, pressure is much more. So if I use a pole and submerge you in Pebble City swimming pool, and if I submerge you in Atlantic Ocean, so the same height, you will feel much more pressure in Atlantic Ocean because the density is more. Have you understood?
What is chlorine?
That is used for disinfecting, adding chlorine in water. If you like, the best example is that it will not happen with you and me. We are little bit, you are less, I'm more, we are more on the melanin content, means we are more dark. If we take, let's put Vanya then, okay, and put diving glasses on Vanya's eyes. Okay, no, let's take Vanya. We have never given her example. Let's put her diving goggles on her and let's make her swim on chlorinated water. When she will come out, na, we'll see panda coming out. You understood? Panda coming out, because this much portion will remain unaffected, rest whole of the body will become chlorinated.
Vaseline lotion का और density बढ़ जाएगा.
हाँ, density बढ़ जाएगा. Vaseline lotion नहीं, गोबर के slurry में अगर आपको डुबाओ तो उसमें, like if I keep you submerged in gobar, you know, the density pressure will be much more. Have you understood? Okay. From this, there is one more thing. Though we will discuss it, because density part has been removed, you should understand this. Okay. Then another very crude analogy of flotation. Very crude analogy of flotation. Okay. We're not going to discuss any buoyancy or anything. Flotation's very crude thing is, if a substance floats, okay, if a substance floats, this you can apply your knowledge anywhere. If a substance floats over a fluid, let's say water or anything, then in that case, the density of the substance has to be less than the density of the fluid. Only then you can float. Please understand, this is very important. If you want to float on something, your density has to be less than the density of the item on which you try to float. And let me give you a very nice example out here. Okay, you must have heard about this planet called Uranus. Uranus is a planet which is made up of all gases. The density of Uranus has been found less than the density of water. The meaning which is, if Uranus could have been bought as a football and had been thrown on Piramcheru Lake, Uranus will float on Piramcheru Lake. Very difficult for us to imagine. Did you understand what I said? The Uranus is a planet which is all gases. In fact, after Jupiter, all the planets are all gases. Uranus density is less than the density of water. So if you could have brought Uranus, anyway Uranus is bigger than Earth. Suppose Uranus was a ball, and bring Uranus and throw it on Piramcheru Lake, then Uranus would be floating. Very interesting. ये याद रखिएगा. For anything to float, the density of that item has to be less than the density of water. Now the question arises, interesting is,
How do we float?
our density is made less, has to be. Otherwise you cannot float. Now you say, how do I change my density? That is by breathing, posture. अंदर जाके बक 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 नहीं करते हो ना, मुंह बंद रहता है. The question comes is iron best. Iron's density is much more than water.
How do people, if our density is more than water, how do people drown? Yes.
If your density is more than water, 100% you will drown. In order to be flat, less means in order to float, your density somehow has to be made less than that of the substance on which you are floating. You forget people. I'll give you a best example. Let's take a small nut of iron, put it in water. Won't the nut get drowned in water? Yes. Iron's density is much more than water. You can Google and see what is the density of iron. What is iron? Anyway, water is 1000 kg per meter cube. Iron is much more. Then how does Olympus and Titanic, they float on water?
It's a small effect.
Yeah.
The shape of the ship. The shape is changing.
So shape of the sheep is made such. But what is the concept?
Like the whole
Hey, All those are textbook. Give a convincing answer which convinces. What you are saying, I am not disputing. That's there in the textbook. That's what people say. I have given you a simple funda. This law has to be obeyed in order to float. So think like a science student. The ship is made up of iron. Iron's density I cannot change. I cannot change the density of iron. But think, can I change it? For the ship, I can change the density of iron. What is the, can I rub this portion? सोचो खाली वो मत बोलो a ship is given a shape, ऐसा नहीं होता है. Density of the ship, is this in your hands or not? I'm just asking that question. Again, you're going by book. First of all, you think, is the density of ship a controllable parameter for you or not? Okay, let's take no first. Why is it not? Why is it not? No, yes बोल के तो फायदा नहीं ना. We are in science class. आपको सोच के बोलना है reason. क्या मैं, okay, let me say I have 1 kg iron with me, Fe. क्या इसका density मेरे हाथ में है, control में है? Think. You are not. You go by this formula. So density is mass per unit volume. Mass of this iron is 1 kg. Is the density a controllable parameter for me?
Yes. You can control the
A needle usually very light. If you make it, a needle will float on water. Float कर जाएगा. ठीक है? ऐसा क्यों हो रहा है? मेरे हाथ में है क्या डेंसिटी? सोचो ना, सोचो. What am I asking? Is the density in my hand? Yes, that is the answer. If you roll out, density is in my hand because I still have the volume controllable in my hand. Think like a science student. मैं volume को control कर सकता हूँ. Take that same needle and suppose I have got a balloon in which I bellow that needle and I make it like the Cadbury's Dairy Milk wrapper. ऐसा बड़ा सा बना लिया, उसको भी पानी में छोड़ दिया, फ्लोट करेगा ना? मैंने क्या कंट्रोल किया? I played with density. I know, first of all, you should ask me, sir, in what shape are you giving me this? What is the size? I said, I have given you 1 kg, like the 1 kg weight of a shopkeeper. दुकानदार के हाथ में जो, ये फ्लोट करेगा? नहीं करेगा. Okay, you are allowed to do anything, but don't reduce the mass. Can you make it float? Yes, sir, I can make it float. मारते इसको malleability दिखा के पतरा बनाऊंगा मैं, इतना बड़ा पतरा बना दूंगा, वॉल्यूम बढ़ा दूंगा. अंडरस्टैंडिंग जोई नाउ? डेंसिटी इज इन माय हैंड. शिप में हम वही काम करते हैं. शिप में जितना मेटल से शिप बना है ना, शिप का वॉल्यूम बड़ा करो. कैसे वॉल्यूम बड़ा करें? शिप का बॉटम ऐसा नहीं होता है जैसे आप सोच रहे हो. द शिप बॉटम इज ऑलवेज हॉलो. द शिप बॉटम इज हॉलो इनवर्ड्स. आर यू गेटिंग इट? इट्स लाइक, हैव यू सीन एक मस्जिद का गुंबज देखा है ना? हाँ, वो शिप का बॉटम भी वैसा ही है. उतना एयर घुसाता है वो अंदर. नाउ नेक्स्ट क्वेश्चन इज, सर सबमरीन जब चाहो नीचे जाता है, जब चाहो ऊपर आता है. हाउ इज द सबमरीन प्लेइंग विद इट? शिप इज स्टिल इजी बिकॉज द शिप विल ऑलवेज बी ऑन वाटर. ऐसे सोचो, सर सबमरीन को कैसे नीचे? दैट मीन्स दे आर प्लेइंग विद द डेंसिटी ऑफ सबमरीन. समटाइम्स दे मेक द डेंसिटी ऑफ सबमरीन मोर देन दैट ऑफ सी वाटर. दैट्स व्हाई द सबमरीन, sometimes it can flush out water. बस simple. So overall a submarine will always float. उसको हल्का ही बनाएगा, लेकिन जब नीचे ले जाना होगा पानी अंदर घुसाएगा बक 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 करके, प्लस उसका वेट बढ़ गया, वो नीचे चला गया. अब एक और बात, जिंदा आदमी डूबता है, मरा हुआ आदमी, लाश हमेशा ऊपर आ जाता है ना. CID वगैरह में दिखाता है ना, लाश क्यों ऊपर आ जाता है? आप ब्रीथ करने से आपका वेट बढ़ता है. Yeah, you breathe in. Can you ever breathe inside the water? The moment you open your mouth, you will go inside. If anyone who, many of you must have swam a little bit this much. Even I am not a good swimmer, or I cannot save you. But this much I also know. If you go inside the water and you open your mouth, तो और नीचे जाएगा. Then suddenly you come out, buk 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 buk, the water will come out. You can't release. नीचे छोड़ दोगे, पानी नीचे ले लिया ना, तो नीचे चले जाओगे. इसलिए तो गांव में जो लोग, ये बच्चे सब होते हैं ना, ब्रिज में से ठपाक झा, पानी खा गया उसका बेटा, इसीलिए डूब गया, पानी खा गया. पानी पी गया। कॉन्सेप्ट समझ में आ रहा है? ये कॉन्सेप्ट याद रखो, बॉयंसी पढ़ो जो भी पढ़ो, डेंसिटी ऑफ समथिंग दैट विल फ्लोट has to be less than the density. Suppose you have taken a Amazon box which has come to you shipped, हम उसको काट के नाव बनाएंगे, छोटा सा नाव बनाएंगे, डूबने का चांस है, न्यूज़पेपर वाला नहीं डूबेगा, पर वी वांट टू मेक द बोट ऑफ Amazon कार्टून बॉक्स ओनली, सो व्हाट शुड वी डू? मेक अ वेरी बिग बोट, वॉल्यूम बढ़ा दो उसका,
Mass will be less.
mass is same, this much of atta dough and the aloo paratha mass is same, however the volumes are different. If you take oil has more density. By now you know what is dense liquid means. How to understand a dense liquid? Difficult to walk on it. Oil density is more. Condensed milk made density is. Suppose there is a small fly, heavy bee or a fly, गंदा सा कीचड़ से आया हुआ फ्लाई है, and it falls on your दूध का कटोरा, वो ड्राउन होने के चांस है, because दूध when you are having it very hot is very very less dense. लेकिन उसको कंडेंस मिल्क के डब्बे में फेंको, एकदम ऊपर तैरता रहेगा. Why? When you have those fudge and all other drinks which are like, you know, fudge drink लेते हो, उसमें अगर आप एक चेरी छोड़ देते हो तो चेरी floats, because the density of the mango shake's density is very much high, therefore the cherry floats on mango. पानी में चेरी छोड़ो तो डुबू करके नीचे चला जाएगा. Yeah, Zoe Marta.
Like heated milk, there's like the thing which.
That's the malai part, the cream part. Yeah,
It's less dense, more dense than the. Like
it's
milk is
froth.
more dense than-
But that is coming up because of convection current.
So
Afterwards the cream is less dense. That's why when the milk settles, the cream will be always on top, which children don't want to have. Suppose you take a jar of cold milk and you take out your saucepan, then you'll always say like this. Otherwise that cream, I hate it when it.
with like,
Density changes with heat, obviously. Yes, the viscosity goes down. The viscosity. Condensed milk is the best example. Ice cream. You melt ice cream is less dense at that time because the volume is spreading up. When you heat something, the volume increases. Got it? So in order to float, our next class we will be taking away from here, but this thing always remember, for anything to float, the density has to be less than the density of the substance on which you want to float. Iron floats over mercury because mercury's density is much more than iron. 13.56 is mercury's density, much more than iron. खुशी iron float करेगा. Like I said, मक्खी floats on दूध, डुबकीज on दूध, but floats on condensed milk. हमेशा गंदा एग्जाम्पल लो तब समझ में आएगा. ऐसे ही तुमको छोड़ दूंगा ना, तुम गिर जाओगे. बढ़िया सा condensed milk and cow dung if you mix and make a slurry, on that you throw Shreyas will be floating on it because the density will be more. ठीक है, चलो, we'll close our class today and read till this much.